Hello and welcome to my ECE5000 project demonstration video. This is for part 6, design, demonstration, and verification. My project is an Arduino based outside temperature, humidity, and indoor light data logging system that uses Node-RED and Thingspeak. The product that I have created is called the Enviro Monitor Plus. This product is designed to continuously log data from the environment and display it in a dashboard in real time. So this project uses the Arduino Uno R4 as the microcontroller, the SHT31 sensor, which is right here and is soldered. The SHT31 allows for temperature and humidity reading, and then finally a LDR, a photoresistor, which you can see on coming out of the side of the box for the hole that is specifically meant for it. This is my final enclosure, and it is 3D printed, made of PLA. Here is the top of the box, and inside you can see it fits very well. It is fit appropriately so that the components inside are not moving around. The hole for the USB is just big enough for the cord and not any bigger for water to come in. And the SDA, SCL, VCC, and ground cables have this hole right here. And as I showed, the photoresistor is the hole is perfectly sized for the photoresistor so that it can access the light when the cover is on. The SHT31 and photoresistor are implemented using the breadboard and different circuits, voltage dividers, in order for it to operate properly, which have been seen in the previous submissions, as I've included circuit diagrams. And in this submission we have the connection details. The Arduino code was written to allow for the functionality of reading sensor data at regular intervals, which is right now set to 2 minutes, but this can be customized for the client who purchases the product. The Arduino code also sets up the Wi-Fi connection and communicates over the Wi-Fi connection with Thingspeak in order to send data. Thingspeak stores and logs the data that it receives. Thingspeak has the read key and write API key. The write key is used in the Arduino code, and Node-RED later uses the read key to access the stored data and display it in the Node-RED dashboard, which I am going to show. In Node-RED, flows are assembled using blocks. The HTTP request block requests the Thingspeak read key and the channel to retrieve data. The data is converted from JSON to JavaScript object, and in the end we have a clear dashboard that displays in real time the data of the environment and the factors that we are measuring and monitoring. In order to show my working prototype, I have started all the necessary programs. So I have my Arduino code running and uploaded right now. Using my Mac terminal, I put in the required command to start up Node-RED. And here I am showing you my Node-RED dashboard. So first I have the inject node, the HTTP request node, which I talked about a minute ago, JSON block, function, which has 3 different components right here: temperature, humidity, and light intensity. Inside these blocks I can set the units and also calibrate the scale. Here is my Thingspeak channel. You can see my channel was created 3 months ago. The last entry was less than a minute ago, and we know that our sampling interval is 2 minutes, and I have had 133 entries from the time that my system has been up and running while I've done testing and different demonstrations for this project. And here we have different entries, and they are coming in real time every 2 minutes. So the data is being read by the different mediums that we have, the SHT sensor and the photoresistor. And because my Arduino Uno R4 has Wi-Fi capability, it communicates over the Wi-Fi connection to Thingspeak, where data is logged and stored. And then from Thingspeak, node red accesses this data and then presents it in a easy to read .live dashboard such as this. So this is the final product of what the client would see if they purchase the Enviro Monitor Plus, so that they can easily and in an automated fashion monitor the humidity, light intensity, and temperature of the environment that they are wanting to. Now, even though we have done a testing video prior to this, I want to show that the product is working by running through some different conditions right now. So in the room right now, it is measuring at 20 degrees, and I am going to shine a light on my photoresistor. So the temperature should be approximately 20 degrees, and the light intensity should be fairly high. So I'm going to show you what the dashboard looks like for this scenario. We can see on the dashboard that this is reflected, so we can see the temperature is extremely accurate, and the light intensity is very high because I was shining a flashlight directly on the photoresistor. Next, I am going to completely cover up the photoresistor to try to get as close to absolute darkness as possible. And there we go. The temperature did not change because I did not alter the temperature, and the light intensity nearly went to 0 lux, which is exactly what we want, and the humidity didn't change either. So this proves that the temperature is highly accurate and the light intensity is as well. Lastly, to show that the humidity is working properly, I am going to go downstairs into the kitchen while someone is cooking, because this will be a humid room. So the humidity should go up. For this last example, I am going to boil the kettle, and the humidity will increase as well as the temperature should increase significantly. After boiling the kettle, we can see that the temperature increased from around 20 degrees Celsius to 66.5 degrees Celsius, and the humidity went to 94% humidity. So I have successfully shown that my product is still working just as it was in the testing video, and we have now done even more test cases. This confirms that humidity, light intensity, and temperature are all recording and measuring properly. Thank you for watching, and please consider buying the Enviro Monitor Plus for your humidity, light intensity, and temperature monitoring needs.